Good morning. My name is Aryan Singh Rana, and in today's video, I'll be explaining you the solution to the question number 3010 in LeetCode with the title Divide an array into subarrays with minimum cost 1. So it is a easy difficulty level question and covers the topics like array, sorting, and enumeration. So the question says that you are given an integer array of nums of length n. The cost of the n array is the value of the first element. For example, the cost of the array 1 to 3 is 1, while the cost of the array 3 4 1 is 3. You need to divide the nums into three disjoint contiguous subarray. Return the minimum possible sum of the cost of these subarrays. So the question is pretty simple. It says that, for example, we have a array and whatever the value of the first element inside that array is the total cost of that whole array. As you can see that it has also explained us that this is the example array which is 1 2 3, and the first element over here is 1, so the cost of the whole array is 1 over here. Similarly, for the second array, as you can see that the first element in this second array is 3, so the cost of the whole array is 3 over here as well. Now what we have to do, that we have to divide the input array that we have been provided into three disjoint contiguous subarray. Now, these two terms, contiguous subarray, is really important. First, the subarray means that the array should contains all the elements inside the provided, or you can say the inputted array. The contiguous means that the elements should be contiguous, or you can say the elements should be in the same order as equal to the inputted array. For example, we have been provided with the array 1 2 3 and 1 2 3 12. We can take the subarray like 2 and 3, but we cannot take the subarray like 3 and 2, because the cost of the subarray is changed, changed, as well as the order of the elements inside the small subarray is changed, which is not equal to the parent subarray or the inputted original array we have been provided with. So the contiguous means that it should be in continuous, or you can say it should be in the same order as the parent subarray that we are deriving this parent array that from which we are deriving the subarray from. So order is really important over here. Now we come to the example number one. You can see that in the example number one we have been provided with the array which is 1 2 3 and 12, and the output over here is 6. The explanation says that the best possible three ways to divide the arrays into subarray is 1, 2, and 3, comma 12. Now, over here, you can say that the division do not violate the order of the original parent array, so that's why it is a contiguous subarray from of the parent array. Now, as we can see that the in three of the subarrays that we have been gotten, the cost of each array is like 1, 2, and 3, and the sum of all three disjoints is 6. That's why the answer we are getting is 6 over here. Now coming to the second example, as we can see that there are only three elements. So when we make three subarrays out of it, then there will be only three subarrays with single elements, which is 5, 4, and 3, and the sum of them is 12. That's why we are getting the output 12 over here. Now coming to the example number 3, as we can see that the nums contains 3, 10, 3, 1, 1, and the cost is getting coming out to be 12. Now, how is that happening? We can make the first subarray like 10 and 3, as you can see that it has been provided over here, and then the smaller two subarrays with the minimum cost would be two subarrays of the cost 1, because as you can see that there are two 1 elements, and we can make two subarrays out of those two sub elements, and the cost would be 1 and 1 each. So the sum of the three subarrays would be 12 over here. Now the constraint we have been provided with is, as you can see that the n can vary from 3 to 50. Now n is the length of the whole parent array. Now why is it giving us 3? Because if it is less than 3, then we cannot separate, or we cannot divide the parent array into three disjoint subarray. That's why n would always be greater than 3 over here. So we do not need to worry about the cases where the length of the whole parent array is less than 3. So as you can say that in the value of the num I, or we can say the elements value, can vary from 1 to 50. Now the code for this is pretty simple. First, I initialize three variables in which we can see that the three variables are m1, m2, and index. Now, why I created these three variables? Now, let me just first clear out the concept over here. So, whenever we make a disjoint of of any array, for example, it is like, just a second. For example, it's like 10, 2, 4, 5, 6, 1, 9. So the best possible subarray in this whole array, three sub arrays would be like, first I'm going to make subarrays of the least elements while taking the least elements at the first index. So it would be like 1 and 9, and the another subarray can be like 2, 4, 5, 6, and the last element would be 10 over here. Now you might be wondering, why did I put sorry, just a second. You might be wondering, why did I put 10 over here? Because I also got a value which is much less than 10, which is 4 over here. Now the problem over here is that when we create the disjoints of the whole array, the first element would remain the first element in any of the disjoints, in any number of disjoints we make. For example, if we make the disjoint of, we plan to make the disjoint of 10 and 2 over here, then even then the first element would remain 10 over here. So as we can see that no matter how we make disjoints, the in this inside the element which is at the first index of the parent array would always remain the cost of the disjoint of the starting disjoint, no matter how we make the other two disjoints. That's why we can always consider the cost of the first disjoint to be the first element of the whole array. So that's why the 10 is always included. And the second example, third example as well, you can see that 10 is all would always be included, because no matter how we make the disjoints over here, this first disjoint would always have the first element as 10, because it is how the because we are making the contiguous subarray, so we cannot change the order, or we cannot manipulate the indexes of the elements. That's why the as I told you, the first element inside the parent array would always be considered as cost of one of the disjoint array. That's why we the answer includes the addition of 10 in any cases, or you can say in any of the solution, you can say that the first element would always be added to the cost of the three disjoints array. Now, uh, keeping in mind that case, I made two variables, which is m1 and m2. I'm using these as like minimum 1 and minimum 2, and I have given them the value of 50. We can also provide them the value like integer dot max value, and similarly for this over here. Just a second. Control C. Control V. Now, why did I choose 50? Because I remember the constraint can go till 50 only. So that's why I used 50 over here. But we can also, just to ignore the constraint, like somebody ignore the constraint, then the universal assignment would be integer dot max value. It is the maximum value that an integer variable can hold. So after that, I created the index. I'll explain the use of the index a bit later. Now I'm using two variables, two loop over here to find my minimum one and minimum two. Now, the concept behind finding the minimum one and minimum two is that for us to get the cost as minimum as possible, we need to make the disjoint which have their first element starting as the minimum inside the whole subarray. For example, as I told you, let me just explain you this from example one only. Now, if we want to make a subarray, we will first consider the two minimum values. We will not we will only find the two minimum values. Why? Because as I told you, if we make the cost of the first disjoint array subarray would always be the first element, so we do not consider the value of the we already know that the value is for first disjoint is always fixed. That's why we always need to find the we can only minimize the summation of second and third disjoint only. We cannot do anything about the first disjoint. That's why we always try to find the two elements which are the minimum in the whole array, so that the cost of the disjoint 2 and disjoint 3 can be minimized, because that is the only controllable factor under us. We cannot control the cost of the first disjoint. So that's why we find the two minimum array, because as you can see that the two minimum elements would be 2 and 3, except for one. We do not consider one. As I told you, that is the uncontrollable factor because it is in the it is the first element inside the parent array. So the cost of the first disjoint would be the same as 1. So as we know that the minimum 2 would be minimum 1 would be 2, and minimum 2 would be 3. So the two disjoints we can make from 2 and 3. That's why we are, as I told you, just to minimize, we are finding two minimums. So first I iterated over the for loop. It would find me the the smallest number inside the whole array, except for keeping the first element of the array out of consideration. That's why I iterated, as you can see, I initiated a for loop with the loop variable as I is equal to 1. Because we are ignoring the first element, that's why, and we know that the index of the first element is 0. That's why I'm iterating from the second element, and the index is 1 from second element. That's why I initialize the loop variable as 1. And the conditions of the whole for loop is as usual, which is that the I can only go up to n dot length, sorry, 1 minus n dot length, because it is strictly decreasing, and strictly less than not decreasing. And the updation command is, as you can see, increment of I after each variable would be y1. Now, as we can see that I am simply finding the most minimum value, except keeping the sorry, we are finding the minimum value inside the whole array, while keeping the first element out of the consideration of the whole equation. Now, as we can see that I initiated a if loop, which says that if the element at the ith index inside the n array is less than m1, then update the m1 as the element itself. So that's how, and I am also keeping track of the index over here. I'll explain you why. So whenever the minimum is updated, the only condition would be that a new value inside the array has been found that is smaller than the m1, and I'm also keeping track of where it was found by updating the index simultaneously with the m1. After that, I go to the another for loop. I initiate another for loop to find my m2, which is second most minimum value. As we can see that the for loop statement is same as the previous one, but there is an exception over here. What is that? I am saying if I is not equals to index. Now why I'm doing this, just to avoid the duplication of the minimum of both of the minimum value, and to ensure that both m1 and m2 are separate values, not the same values. Now what could happen over here is that if there are two minimum values like 1 comma 1, let's just say another one. Now the m1 and m2 would be this one over here and this one over here. Now what happens is that sometimes if we do not consider this condition over here, sometimes we can get two minimum value which are of equal magnitude, which are of equal magnitude, and the array would simply find that one, and it would simply add that inside the cost. Now, or you can say that if there were only two elements, for example, now the array would iterate over the whole array. Just means just a second, let's make it like this. Now first m1 would store the value of 1. Now the second loop would be initiated, and it would see that okay, 1 is minimum, but m1 already holds that, and we do not have a tracking system to see if the value that m2 is storing is same as the value that m1 stored. That's why I used index over here, just to keep the track that just to prevent the storage of whatever the element the m2 is storing is not equal or is not at the same position which m1 stored. So that's why if I is not equal to index, then it would simply iterate through each and every element, and it would find out the second most minimum value inside the whole array. Now after that, I'm simply returning, as you can see that, and the zeroth element, or you can say the first element at the zero index inside the n array plus m1 plus m2. Now this, as I told you, this is mandatory. We cannot control this factor, because no matter how we make disjoints, the cost of the first disjoint would always remain the first element inside the whole parent array. And the controllable factors through which we can minimize the whole cost would be m1 and m2. And through these two for loops, we minimize the whole cost by finding the two most minimum values, uh, which are at different index, and after that, I simply return the sum of it. Now I'm simply running the code. As you can see, all the test cases have been passed. Now I'm submitting the code to further test with more test cases. As you can see that my solution is been successfully accepted, and I beat 99.31% of the rest of the users who submitted or solved the same question using the Java as as their language. Now coming to the time complexity of this whole code, the time complexity of this whole code is dependent on these two for loops, and as we know that the for loops are only iterating n minus 1 times. Why? Because we are ignoring the first element in both of the loops. So we can say that in if we sum both O of n minus 1 and O of n minus 1, the resultant would be O of n, which is constant, which remains constant because we know the number of iteration would only be n minus 1. That's why the time complexity of this whole code would be O of n, or you can say constant. Well, that's all for the solution for this problem. Thank you for watching.